Hello, everyone. How you all doing today? Happy Sunday, happy Palm Sunday for the Christians, mostly the Catholics. And I'm really glad you could join in. Or if you decide to join in some other time or watch at a different time. I don't know. There was a time switch. Last night, we went 1 hour ahead. We're no longer, it was supposed to be 5 p.m. now, but it's 6 p.m. I hope that didn't mess up with your programs because it definitely did with mine at some points in time. So, welcome back. I'm glad you're here. I'm really happy to have you here. If you're the first time joining, if you're joining for the first time, please like, subscribe, and turn on your notification bell. Here we talk about life, we talk about career, we talk about everything pertaining to my life, my experiences, and also I would love to hear your own point of view. If you're joining in from any area, you're new here, please let me know in the comment section, and I'll really be glad to have an interactive session with you all. Let's kick it out. Last session, we talked about why DevOps exists. We talked about the problem in the software development lifecycle. We talked about why the old way was not enough and why the industry needed a better way to work. We talked about how DevOps is not mainly about tech and that DevOps is a system for reducing friction between people, processes, and outcomes. If you missed the session, you can just go to the recordings of the live sessions and watch the part one, why DevOps exists. So we also talked about the simplest truth. What is that? How a developer creates code or creates change, not only code, he creates change. So someone who designs and builds a solution to a problem, we'll call them a developer. And who is operation or an operator? The operator or operations protect stability. Someone who ensures the system runs reliably, consistently, and safely. That's the role of operations. So everything else in between is just details. Very important details also, I must add. Now, today, I want us to go a little further. Today's session is about how code moves from the developer's laptop to production. There is really no hands on here. I want you all to understand the journey. I'm going to explain in very simple terms, such that a lot of people who think that DevOps is hard or DevOps is complicated should understand. But when you really understand the flow, it becomes much easier. By the end of this session, I want you to clearly understand this journey. Understand the journey from code to version control, to build, to test, to package, deploy, monitor, have changes, and repeat the process all over again. If you understand all of these processes, then my job for today is done. So, let me start with a question. Have you ever seen a project that worked perfectly on someone else's machine, but when it got to the real environment, it starts behaving differently? There is this common joke, right, that DevOps engineers make. They say, oh, but it worked on my machine. Why isn't it working on your machine? Or why isn't it working in your own environment? This gap between it works here, it doesn't work here, this gap is what we're talking about today. And that's what DevOps a culture is meant for. It's meant to bridge the gap. So, writing code is only one part of software development. The real question is, how do we move that code safely and reliably to real users? The developer has the code. It is well, it is fine. But how do we move that code reliably? That it doesn't change. It doesn't affect other environments. It doesn't affect other tools. It doesn't affect other aspects. How do you move it reliably and safely? So that is where DevOps comes in. So in this session, I'm not going to throw many tools at you. That's not the purpose. The opposite is my mission. My mission is to first help you understand the journey. Because once you understand the journey, then the tool starts making sense. Get it? So let's begin. Let's start with step one, the simplest of all. Code is written, right? It all starts with code. When you plan, you go and code. Now, some people say, what is code? Most people think that code is Python, Java, YAML, all these programming languages. I say, oh, I'm a coder. I code. I code in Python. I code with Java. I code with this. I'm Go. I'm this. I'm that. But code, in its essence, is a set of instructions that turns an idea into a repeatable outcome. If you have an idea and you like structure it, bring it together, so you can do the same process over and over again. Turn an idea into repeatable outcomes, instructions, set of instructions to turn idea into repeatable outcomes. That's the simplest way to define code, in my opinion. So in software, code is like the instructions for machines. The machines receive instructions through code. Say, oh, it is coded. Oh, I want to code something into the computer. Take a normal life example like a restaurant, right? In a restaurant, what can code be? Code is a recipe, a set of instructions. You want to make any type of meal, boil water, add a pinch of salt, put this ingredient, put this, put that, put this. If you can repeat that over and over again, that's code. It's a set of instructions. It's called coding. So don't get intimidated by the term code. So in software development lifecycle, the first thing is simple. The developer writes code. He's a developer. He's passionate. He writes the code. And what can this code be? The code can be a new feature for an existing application. The code can be a bug fix. You want to fix something. A code, maybe it is an important update or improvement to an already existing application. At this point, all of these processes, the coding processes, which can be any of the three mentioned, is happening locally. The developer is sitting on his computer or her computer locally writing this code. The code is still private. Nobody knows about it. The code is local. Local means private. In my private machine where I am, that's where the code is. It is still incomplete in the sense that the rest of the team has not seen it yet. So the journey begins here with code. It begins there with code. Because when you do something, you say, okay, it looks good to you. You have done the initial work. You have created the code. You have created the change. Now, what's in the next step? Let's go to step two. Step two is called Git and version control. Now, once the code is being written, it needs to be saved in a place where the team can track it. You created the code locally in your machine. Now you said, okay, one team member is in Dubai, the other one is in the United States, you're based in Germany, and you said, okay, they need to see this code, or I need them to see this code because we're a team. They have to see what I'm doing. So you use Git, and this is where Git comes in. If you're doing anything in IT, in a team, you must know how to use Git. So we shall talk about that detailing later. So Git is a version control tool. And what that means in simple language is Git helps you keep track of changes. Git helps a team work together. It helps you know who changed what. and it helps you go back if something goes wrong. So with Git, you can go front and back and know who did what, who did this change, and it's good for remote work. So instead of code just sitting in one person's laptop, it moves into a shared system where it can be managed properly. And this movement is being managed by with Git. So yeah, source code management. That's also a term for it. Or version control tool. People call it different names, but just for version control, know who did what. This is important because software is not built by one person. It is usually built by a team, and the team needs structure. Git helps in providing that structure. So now, step 3, the code is pushed. Step 1, code was created or written. Step 2, we use Git version control management so the team, no matter where they are in the world, can see the team to maintain structure. Step 3 is the code is pushed. After the code is ready, the developer pushes it to a repository, and he uses Git to do this pushing into a repository. And the code resides in the repository. The repository also is part of Git. Mostly, the most common one is GitHub and GitLab. Think of this as sending the code from your local machine into a team's working space, from your local working space into the team's working space. Once that happens, the code can now trigger other actions automatically. So when you do git push -m, whatever the change was named, some automatic processes start happening behind the scenes. And that's automatic. And that at this point, this is one of the beauties of DevOps. When you're able to push the code and some automatic actions start taking place. The moment the code is pushed, the system does not have to wait for someone to manually do everything. Some things can happen automatically, and they actually do happen automatically. So this is the beginning of a process called automation. Let me check in the chat if we have any questions. No, nothing at the moment. So let's continue with stage 4. Stage 4 is the build stage. Build simply means preparing the code so it can run properly. And this build now happens remotely. I already push the code, right? The build stage now, every team member can watch the code being built because it's already been pushed into the remote repository. And every team member can see now what you did. If it succeeds, they see. If it fails, they see, and they can analyze why it failed. But it is your duty to correct anything that happens. So let's talk more about the build stage. In many projects, code does not just run immediately after someone writes it. It needs to be assembled, checked, or packaged in a way that makes it ready for the next stage. So what happens in the build stage? In the build stage, the code is being prepared properly. What does that mean? It means that sometimes code needs dependencies, right? It collects dependencies. Sometimes code needs to be compiled, the compilation stage. This is where the system gets ready for testing or deployment. Think of this building stage. Again, let's go back to the restaurant analogy. Before you cook, you have to bring your ingredients together. So, but they still need to be organized before the full meal can be served. So I hope this example makes sense. I took the restaurant analogy because we can easily relate to food, right? So if you want to cook, you get your Maggi, you get other things. There's some other things that you say that, oh, this needs to be here. It needs to work together with this. Now, you've built it. The building stage is complete. It passed. What next? Step 5, testing stage. After building the code, we test it. This part is all the parts are important, but there are some crucial parts that must be done because no matter how good a developer is, mistakes can be made. A line of code can break something, a feature can behave wrongly, an update can affect another part of the system. So, testing helps catch this problem early on. Let me give an example. Sometimes at work, when I do an update, let's just say that the typical one is to update our Kubernetes, right? If you're updating the EKS, say moving it from version 1.32 to version 1.33, it looks simple that you just go and just change. But there are several dependencies, there are several other applications that are linked to the Kubernetes, which means that you have to check and test that this change, how is it compatible with other applications that are dependent on Kubernetes to work? So when you do that update, don't just say, oh, I've updated it, we're up to date. No, you have to test it. And testing in the sandbox area, test it to see that this change I have made, let me test it here. How will it interact with other applications running in our system? And sometimes you see that, oh, when you run the test, you see the lines of messages that comes up and says that this version is not compatible with this. It's not compatible with Istio, as that was a common error or a common problem we ran into when updating our Kubernetes at some point in time. So when you see that it is not compatible, you either downgrade or you maintain the version at a point in time, or you can see that the compatibility, can we still work with it? But I don't think it's not recommended to work with incompatibility though. So those are one of many examples why it's important to always test what you're doing. So when testing, there are a few questions you need to ask yourself. Does this code actually work? Does it do what is expected? Did the new change break something else? Because sometimes we're just happy to say that, oh, it worked, I built it, yay, the pipeline is green. You have to go and test it. And that's when things are really like, okay, testing stage. Whenever you do something, they ask, did you test it? In what environment? In the sandbox, yes. You have to test it too in the developer's environment. So I'm going now out of context. So testing is not punishment, right? Testing is protection. It protects the users, it protects the business, and it protects the team from releasing broken software. There is this terminology that you break it, you fix it. So I don't want to break anything because the little action that broke a software, you need to multiply the intensity of the hours you invest by 100 at least. Because sometimes when you break something, you just took one action to break, but you need like more actions to repair it. So testing it is very important. Now, let's go to step 6. Step 6 is packaging, right? So you've built it, you've tested it, everything looks good. What do? You package it. Once code has been tested, it often needs to be packaged so that it can run the same way in different environments. And this packaging is very important. This is where in upcoming videos, we'll talk about the packaging tools like containers. The problem that says that it works on my computer is but it worked on my computer. The packaging here should help eliminate that sentence because the code should run the same everywhere in different environments. So I just mentioned containers can come in here. But for now, as I said, let's keep it simple. So we talked about what packaging is, right? Packaging is like putting the container, not the container. Packaging is putting the software or the product in an environment where it can travel safely. You package it. This is very useful because one of the biggest problems in software is that something works on one environment and fails in another. I already talked about that. So we want to avoid that. Packaging helps reduce that problem. Let's go to step 7, that is deployment. After packaging comes deployment because you have packaged it, you know that it's already ready to go. Let's go and release it, deploy it. Deployment means putting the application into an environment where users can actually access it. Like just come and put it on the bookshelf. This is the moment the work moves from being internal to becoming real for users. The users just want to consume the product. They want to consume the application. So once it's out for consumption, it should be ready to be consumed without error. And deployment is one of the reasons DevOps is so important. In the past, what used to happen? In the past, development and operations were often separate. One team wrote the code, another team tried to put it live. And sometimes the handoff between them was messy. So we see now that the handoff is not really messy. The handoff, it is like a system, it flows, a culture, the processes, they are trying to make the lines blurry. They're trying to make the line blurry between operations and development. You see that there is no really clear handoff, it's a system. So once the developer develops the code in his local environment, he pushes the code, he builds the code, he tests the code is ready for deployment. This is mostly now towards operations, but it's so blurry that sometimes one person can be developer and operations. Some people are developers, operations, and testing, that different people within a team that do separate things. But as DevOps is a culture where you integrate those things. So DevOps helps make that handoff smoother. It helps automate it. It helps reduce delays and it helps reduce human errors because of there is the automation part. So this automated part helps reduce human error because it's not manual. Now, once it is deployed, tested, deployed, handed over for end user consumption, the job is not yet done. There is another step, step 8, called monitoring. Now, many people think the work is done after deployment. No, the job isn't done after deployment. But in reality, deployment is not the end. In reality, in anything, deployment is not the end. You need to get feedback. Some people call it feedback, but to get feedback, you have to first monitor. Such that when you see the feedback, you can say, oh, is this feedback, does it relate to what we actually saw? Did we see this problem? And if we didn't see this problem, how can we make it better? Our monitoring systems. So after the software goes live, we need to monitor it. When monitoring, there are some particular sets of questions you need to ask yourself, or we need to ask ourselves, I included. Is it working well? Are users having problems? Is the system slow? Are there any errors? Is anything failing in production? Monitoring helps us observe the system after release. It helps us respond quickly and helps us use improve methods, not methods, and help us to improve the version of the code or the version of the application. No longer code, yeah, the code is still inside the application. So yeah, we can say update the application, which means that working on the code itself. Monitoring, a whole team is designed for monitoring. And this is a typical interview question, right? They always ask you that, what monitoring tools have you used? You should best have learned to use any of the monitoring tools or have witnessed how the logs, look at the logs. The most simplest way is the AWS management console. When you deploy an application in an EC2, you check the logs and see, oh, what's happening here? Between 5 p.m. and 6 p.m., there was a spike. You're observing what happened in that spike. And there was a drop. You measure, why did it drop? Or you see that many people try to log in or log in failed, read the logs, failed log in, failed whatever, or no errors at all, then that's good. But monitoring is a very important step. After deployment, the job is not done. It continues with monitoring, learning, and improvement. Our team lead, the first hour of the day, they spend going through the logs and the dashboards, because when you do look at the monitoring, is attached to dashboards, right? When you monitor, you need to like send that data to a board. You know, with the board, you can easily visualize it to see what's happening. You can see the timestamps. You can see the upward and downward movement on the graph. It gives you a better view of what's happening. I don't think it's not only in the software development life cycle, it's in every walks of life. A business person say, show me the numbers. And sometimes the numbers are plotted in a pie chart, whatever chart, but the monitoring helps you know, what are you doing? Is it working? Is it not working? And if not, what can be done? Is it working? Can we do more of that? So it's not the end of it. It's just a point where you can take stock and say, okay, let's do this differently, or let's stop doing this and start doing this, or let's continue doing this. Of everything, that's a learning curve in the software development life cycle. So let's bring this all together. DevOps flow looks like this. A developer writes code. The code is stored in Git. The code is pushed. The code is built. The system built it, not the code. The system built the code. The code is tested. When it's tested and it's successful, the application is packaged, the application is deployed, and after deployment, we monitor it. So this is a journey from code to production. If you have understood this journey, I believe that it is much easier for you to comprehend or to understand why certain stages are important and certain tools are important. Now, if you are new and want to start learning DevOps, please do not try to learn everything at once. Excuse me. Start with the basics. Start with Git. First of all, you have to first start with Linux. We'll talk about this next week again. Start with understanding the software flow. Start with the idea of build, test, deploy, and monitor. Understand all of those. You do not need to master every tool before you can understand the process. First, understand the process, then the tools will begin to make sense. So, let's take this home. I want you to remember this. DevOps is not just about tools. I've said this, I think I've said this from the beginning. I started talking about DevOps. It's not about tools. It's about the journey of code from development to production in a safe, smooth, and repeatable way. If this session helped you, then this is in the next session, we are going to connect this flow to some tools on AWS so you can see how these tools live in the cloud. I don't know, nobody had some questions here for me. I'm glad I got to simplify this journey for some people. If you feel that you need more, if you feel that you need someone to hold your hand and explain this to you in a more confined and not confined environment, in a more personal environment, send me a DM and I'll be glad to accompany you along the journey. So thank you for tuning in. Thank you for listening, for watching. Tomorrow, or no, not tomorrow, next week, we shall talk about DevOps in an AWS environment. Let's see the tools that are being used there. So have a great day. Enjoy the rest of your weekend and bye.